So here, as we move on, we're going to start to look at hypothesis testing, specifically with the new distributions we've been looking at. So as we read through this, a company claims that 1 in 8 of their packets of crisps contain a prize ticket. Lee decides to test this claim and buys a packet of crisps each day until he finds a prize ticket. So at that point, until he finds a prize ticket, that lets me know we're working with the geometric distribution, because finding a prize ticket is the first occurrence, it's the first success, it's a geometric distribution. Alright, so let's just go out and define that distribution, and we already know that the probability is 1 over 8. So the null hypothesis is going to be that it equals 1 over 8, and reading on, we're testing whether the company is overestimating the proportion. So the alternate hypothesis is that the probability of getting one is actually less than what they tell us. Okay, as usual in a hypothesis test, let's state the expectation and the significance level. The expectation, is 1 over p. It's the reciprocal of the probability. Okay, quick diagram just to make sure that everything's clear. Expectation is going to be here at the peak. And to be convinced that they're overstating, I would expect to take a lot of attempts to get a success. So critical region is over here in the right tail. In the question, we're told that Lee finds a prize ticket for the first time on the 24th day. So let's just think where 24 would be. It's above the expectation, so we're looking for greater than or equal to 24. Alright, we know how to find that probability. It's going to be q to the power of 23. So that's 7 over 8 to the power of 23. Gives us a probability of 0.0464. And we just make a comparison with the significance level. It's lower than the significance level. It is a significant result, so we can conclude that there is enough evidence to reject H0. And in context, there is enough evidence to suggest that the company is indeed overstating the proportion of packets which contain a prize ticket. Okay, so a lot that we've seen here is exactly the same as the format we usually have for a hypothesis test. We state the distribution and the expectation. We state the hypotheses. We draw a diagram depicting the critical region or the probability that we're about to find and compare. We calculate that probability. We make a comparison, and then we draw our two conclusions, one mathematical and one in context. The only difference you'll see here is that we actually have a new way to calculate our test statistic. We actually have a new way to find the probability that we're going to compare with the significance level. Apart from that, all the hypothesis tests that we conduct going forward, no matter how complex they are, will always have this same formatting that we've got used to through year 12 maths, through year 12 further maths, and now we're seeing in year 13 further maths. In this next question, we're looking at an electrical company which makes components and claims that the percentage of defective components is only 0.05%. Now, a retailer buys these components but suspects that the percentage is actually higher. The retailer decides to conduct a test, and in doing the test, he's just going to keep on testing individual components until he finds a defective component. So finding a defective component is finding the first defective component. It's a geometric distribution once again. Alright, be extremely careful here with the probability. This is 0.05%, so there's going to be a lot of leading zeros when you write this out as a decimal. It's 0.005 as the percentage. This time round, the suspicion is that the company is understating the percentage. The retailer actually thinks the probability of it being 40 is higher. So the null hypothesis is that it equals that probability, and the alternate is that it's greater than that probability. So from here, as usual, we should be drawing a diagram and we should be generating the expectation. Let me just throw in the significance level. The expectation is 1 over p. In this case, that means that the expectation is 2,000. I would expect to examine 2,000 components before I found the first 40 component. Just keep that in mind. Okay, on the diagram, 2,000 is going to be here at the peak. That's the expectation. And in this particular instance, we found the first faulty component on the 90th component. So that's over here on the left. That's already suspicious. That came too early. But is it suspicious enough to conclude that we should reject the null hypothesis? Is it suspicious enough to be a significant result? Let's go ahead and calculate the probability that x is less than or equal to 90. We know that that's 1 minus q to the 90, failure to the power of 90. It's everything except 90 failures. And we calculate that to be 0.0440. This is smaller than the significance level. This is indeed a significant result. This probability is extremely small compared to the significance level we set. So we conclude we have enough evidence to reject H0, and obviously in context, we conclude enough evidence to suggest the retailer is correct and the percentage of defective components is greater than 0.05%.